Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and today we're going to be doing Unit 10, Lesson 5 on the circumference of a circle. Now, in the last lesson we learned about the technical definition of a circle, and we also learned about the radius of a circle, i.e. the distance from its center out to any point on the circle, and the diameter of a circle, which was the maximum distance across a circle, right, which is basically the length of any line segment that starts on one point on the circle, ends on another point, and passes through the circle's center, right? These are going to be key ideas as we move into the lesson today and as we learn what in the world the circumference of a circle is. You're also going to need your calculators today, so make sure to have those handy. And let's move on with this. Now, we've measured the lengths of straight line segments, right? We've done that both with rulers and we've done it with just like, here's diagrams and those lengths are labeled, all right? We can also think about the distance around a circle, known as its circumference. The circumference of a circle, right? The length of the curve that encloses a circle is known as its circumference. It is like the perimeter. It is basically identical to perimeter, right? It is the distance around a circle. The only difference between perimeter and circumference is that the perimeter is the sum of straight line segments that enclose polygons, and the circumference is the length of the curve that encloses a circle. Right? The figure below shows the idea of unwinding a circle to make it straight for measurement, right? This idea that here if I had a circle and I literally just started to unwind it, right, that length would be the circumference. Or if you want to think about it this way, take something that's circular, anything that's circular, take a piece of string, wrap it around that circle, take the string off, and stretch it straight. The length of that piece of string, that's the circumference of the circle, all right? So today we're going to look at how we can calculate the circumference or the distance around a circle. And in the next lesson, not this one, we'll then talk about how to find the area inside of a circle. Here, we're just talking about the distance around it. So let's get into that, okay? Exercise number 1. Circle C is shown below with points A and B forming a diameter. With a ruler, measure the length of the diameter. All right, this is easy enough. Why don't you pause the video now, figure out the length of that diameter in units of centimeters. All right, well, I made this one come out nice, I hope. Again, this is all based on my original worksheets, but that thing is 10 centimeters. All right, so 10 centimeters long. Let me move that up out of the way. Now, this is where it gets a little bit tricky in this lesson. You're going to need pipe cleaners, right? And those are those kind of fuzzy things that are around metal, okay? Or something like that that can be bent along the shape of this curve. So let's take a look at what you're supposed to do in letter B. Use a pipe cleaner the length of the diameter to mark off diameter lengths along the circle. In other words, right, I want you to take a pipe cleaner and I want you to stretch it out along here and either cut it off with a pair of scissors or something like that so that it's 10 centimeters in length, okay? And then I want you to mark off diameter lengths along the circle. Now that means you'll have to take the pipe cleaner and bend it so that it's in the same kind of curve as the circle, but I'd like you to do that in letter B and mark off those diameter lengths along the circle. All right, well, it's nearly impossible for me to do the same thing up here. Nearly impossible. Because when you say something's impossible for me, well, maybe I can still do it. So here, I've got one of those curves, all right? So I can come in here, and this is a curve that is exactly the same length as the diameter. I'm going to put it right there. And let me try to get rid of this. Let me get another one, hopefully. Here's another one. I'm going to put it right there. And I think I've got another one here. Let me just take this one and drag it up to here. And I'm not going to get any more in there, right? So I've got 1, 2, 3 of them, and then there's a little chunk left over, right? There's a little chunk left over that I really can't do much with, right? It's way longer than the diameter of a circle, but at least we can, at least we can answer letter C, right? To the nearest whole number, how many diameters lie along the outside of the circle? Well, 3 of them, right? Now, it's a little more than 3, right? But to the nearest whole number, I can only get 3 of them to lie in there. And that then gives us at least an estimate in letter D of the circumference, right? I know that each one of these things is 10 centimeters long. I know that each one is 10 centimeters long. So I can say that the circumference, which I use as capital C, I'm going to use what's called the approximation symbol. These 2 wavy lines is going to be 3 times 10 or 30 centimeters. Now, it's definitely a little bit longer than 30 centimeters, right? Because there's this little extra bit that I can't quite get in there with those 3 diameters, all right? But it's close, right? And really what I'm saying is I'm saying that the ratio of the circumference to the diameter is just about 3, a little bit more. We're going to explore exactly how much more in the next exercise. So let's go there. All right. All circles can be scaled up or down so that the number of diameters that can be placed around a circle is always the same and is always slightly more than 3, right? So it doesn't matter how big the circle is, you can get 1, 2, 3 diameters and then have a little chunk left over, okay? Now what we really want to do is get a sense for that exact ratio, right? So what do we get? How many diameters fit into a circumference? Well, you do that by division. So let's take a look at exercise number 2. The table below gives the diameters and circumferences for 5 circles. The circumferences have been rounded to the nearest hundredth. For each, divide the circumference by the length of the diameter using your calculator, round to the nearest hundredth. And again, let's just be very clear about what you're doing. When you take the circumference and you're dividing it by the diameter and putting down the number here rounded to the nearest hundredth, you're finding out how many diameters fit into the circumference, or better yet, how much we would have to multiply the diameter by in order to get the circumference. So let's do the first one together. And this is simple. This is just calculator work, right? If I take my 15.71 and I divide it by a diameter of 5, I get 3.142, but I'm going to round to the nearest hundredth, so I get 3.14. Okay? What I'd like you to do is do that division for each one of these and continue to round it to just 2 decimal places to the nearest hundredth. So do 40.84 divided by 13, etc., and see what you get right here. Pause the video now. Now, I want you to remember, all of these circumferences have actually already been rounded, okay? So there's a little bit of a kind of a rounding error that's introduced when we do this division because the circumferences are not exact. But let's do another one together. So we get 40.84 divided by 13, and that gives me, again, 3.14 when I round to the nearest hundredth. Now, I'm not going to torture you and do each one because the plain fact is this ratio keeps being that number. Each time when I do the circumference divided by the diameter, I get the ratio 3.14. Right, now remember from that last exercise, right, we saw that just about 3 diameters fit around that circle. The extra little bit is the 0.14. 0.14 diameters, 14% of a diameter, right, is that little extra bit, okay? Now again, make sure you understand what this number really is telling you. This number is telling me that the circumference is always 3.14 times the length of the diameter, right? If I do circumference divided by diameter and I get 3.14, that means the circumference is 3.14 times the diameter. And this introduces us to one of the most important ideas and numbers in all of mathematics. The ratio of the circumference to the diameter in a circle is such a famous number, it's given the Greek letter pi, P-I, which you just pronounce like pie that you'd eat. All right, it's this symbol, which kind of looks like, if you want to just draw it easy, you could just draw 2 vertical lines and 1 above it. That's a completely okay way to write a pi. Pi is 3.14159264, etc. It's actually what's known as an irrational number. The decimal never ever repeats. It goes on forever, all right, without repeating and without ending. It's really cool. And you'll learn more about irrational numbers next year in Math 8. But pi is possibly the most famous irrational number, right? And we all know that rational numbers, their decimals either terminate, like 0.25, 1/4, right? Or they repeat, like 1/3, 0.33333333. Pi never repeats and it never terminates, all right? Now, that being said, right, how do we use it? Well, we use it to calculate the circumference of a circle. If the diameter of a circle is d and its circumference is c, then the circumference is simply pi times the diameter, where pi has a value of approximately 3.14, but we should use the pi button on the calculator when possible. So let's actually make sure we know where the pi button is on our calculator. All right, now, you know, depending on what calculator you have, the pi button is gonna be in a different spot. For me, the pi button is right here above where I enter exponents. And specifically, if I type it in, I get a little pi symbol, and then if I hit enter, I get the value of pi, 3.141592, etc., etc. All right? By the way, some people make a game out of memorizing the digits of pi. I don't know what the world record is, but I think it's around something like 100,000 digits. And again, remember, that's pretty tough because the digits of pi go on forever without repeating in any kind of given pattern. Okay? Really, really awesome. But we want to use that pi button on our calculator to be able to figure out the circumference of circles. So let's take a look at that in our final exercise, number 3. Find the circumference for a circle with each measurement given. Round your answers to the nearest hundredth, show your calculation. So this is super duper simple, but it is just plugging numbers into a formula, right? And a formula that we kind of just sort of came up with using the experimentation in exercise 2. But it's this simple, right? I want to know the circumference of a circle whose diameter is 15. So circumference is pi times the diameter, which means it will be pi times 15. And all I need to do now is take my calculator, and I really do need a calculator for this. I'm going to do pi, hopefully, pi times 15 equals. And that is now 47.12, etc. I want it to the nearest hundredth, 47.12 inches. Now, let's talk just a little bit about units. Circumference is not area. Circumference is distance. It will have whatever units the diameter does. So if the diameter is in inches, the circumference will be in inches, specifically here 47.12 inches. Now remember, the circumference is always roughly 3 times the diameter length. So 3 times the diameter length would be 45 inches. This is, of course, a little bit bigger because of that extra 0.14, right? So it's 47.12 inches. Why don't you go ahead and find the circumference in both B and C, but then leave D, E, and F, and we'll talk about those in a minute. All right, let's do it again. I'm going to keep writing down circumference equals pi times diameter, again and again. So circumference equals pi times 28. And again, pure calculator work here, really easy. We're just going to do pi times 28. No, that's not what I wanted. Let me clear that out again. Let's try to get pi again. Pi. It does not want to light up. There we go. Times 28 gives me 87.96 centimeters. All right. Easy enough, right? I am literally just taking the diameter and multiplying it by the number pi using my calculator. Here, the circumference is going to be pi times 125. Again, easy. We'll just do second, pi. It really doesn't like that. There we go, pi times 125, enter, and 392 point, and let's talk about the rounding on this a little bit. This is a little bit of a tricky rounding. Let me write out actually the decimals. It's pretty hard to see it on the calculator, right? I'm supposed to round this to the nearest hundredth, meaning I must have 2 decimal places. Now, if I'm going to round that number to the nearest hundredth, then I'm going to look at that number. Now that 9 tells me I should bump this 69 up to a 70, right? Normally all I have to do is make that 1 larger, right? But this one's a little bit tricky because, you know, if I go 1 larger than 9, I get to 10, in which case that 6 should become a 7 and that 9 should become a 0. So ultimately, my circumference here is 392.70 miles. That might seem kind of silly, but you could have very large circles, right? Maybe you've got a circle that is the, you know, it's the dome of, you know, something, or maybe it's a giant field, circular field, or something like that. And it might be important to know the distance around that circular field. Now let's take a look at the last 3. These aren't particularly all that difficult, but the one thing that's a little bit tricky about them is that in each case, the length of the radius of the circle is given. Now the circumference of a circle is pi times its diameter, not pi times its radius. And yet, here, I'm given the radius. Remember, the diameter is always twice the radius. So if I'm given the radius, I can easily produce the diameter. So for letter D, the diameter is now going to be 12 inches, and the circumference is going to be pi times 12, right? Bring this thing up. Okay, I'll do pi times 12, and my circumference, again, this is another one of those weird ones, 37.70 inches. In fact, it's kind of rounded very similar to the one right before. All right, pause the video now and come up with the circumferences for these 2 circles where the radii are given. All right, let's go through them. In this particular one, the diameter is twice the radius, so that's going to be 20 centimeters. The circumference now is pi times that 20 centimeters. And let's see what we've got. Okay, clear that out, clear it out. I'm going to do pi times 20. And that gives me 62, at least no weird rounding here, 0.83 centimeters. Okay, and finally, right, when my radius is 30 meters, my diameter is going to be 60 meters. My circumference is going to be pi times 60. And let's get that one. Pi times 60. And I get another one of these weird rounding ones. I get 188.50 meters. Okay. Take a look at those, make sure that you've got them all right. All right, let's wrap this up. I think the idea of the circumference of a circle is a simple idea. You know, take a soda can, take anything that's got kind of a circular cross-section, take a piece of string, wrap it around until it just touches itself, then unwrap the string and find its length. That is the circumference of the circle. The thing that's remarkable about the circumference of a circle is it's always just about 3 times the distance across the circle, known as the diameter of the circle. But it's not exactly 3 times. In fact, it's exactly pi times the number of diameters, where pi is about 3.14. All right. Now, we shouldn't use 3.14. We should just use the pi button on our calculator when at all possible. If for some reason we had to be in a pinch, we could use 3.14. If that was problematic, we could use 3.1 or even just 3. If you were just kind of like really estimating, you know, the circumference of a circle, you could totally, given its diameter, say, well, about 3 times that. But really, you want to multiply the diameter by the number pi, 3.141592, etc., to get your exact circumference and then round to whatever level of degree of accuracy you need for the particular problem. All right. So we're going to work more with circles in the next lesson, and we're now going to see in the next lesson how to calculate the area inside of a circle. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.